Hi guys. So today we're moving on to a new section, 3-3. And today we're going to focus on solving problems that have multiplication or division in them. So yesterday, I don't know if you noticed, but all the problems had adding and subtracting. So today everything will have multiplying and dividing. And then tomorrow we'll put it all together and solve multi-step inequalities. Before we solve our multiplication and division problems, I need to talk to you one more time about some special new things that happen when we are solving an inequality versus solving an equation. So yesterday we talked about one new thing about solving an inequality, and it was something that happened kind of at the end of the problem. And it was that when you were done with the problem, you might have to flip your inequality around. And so one of the times that you need to flip your inequality around is if you finish the entire problem, you've solved for x or whatever the variable is, but the final answer, the letter is on the wrong side, which is the right side. So the variable is not supposed to be on the right side of the inequality. The variable is supposed to be on the left. It's supposed to go letter, inequality, number. And so if you're done with the problem and it doesn't start with a letter, then you're going to have to flip your inequality around. We did an example of this yesterday. So here's another example. We have 3 is less than x. You're not allowed to have that as a final answer, particularly because you're going to graph it incorrectly. And so we're just going to flip everything around and we change it to x is greater than 3. And so that's one scenario for when you need to flip your inequality around. Today, we're also going to learn a second scenario of when you need to flip your inequality around. It is specific to multiplying and dividing. So it has nothing to do with adding and subtracting, which is why we didn't learn it yesterday. And the second scenario is, if the number that you are moving by multiplication or division is negative, then you need to flip your inequality on the very next step. Okay, now, so that would be the number that's right next to and connected to the letter x. If that number is negative, when you move it to the other side, you're going to need to flip your inequality. Let's do an example. So here I have a problem. It says negative 2 times x is greater than or equal to 5. And so to solve this inequality, the negative 2 is being multiplied with the x, so I'm going to do the opposite of multiplication, which is division. So I'm going to be dividing by negative 2. Now, as soon as I write down that I'm dividing or multiplying, and I check to see the number, now it's the number that you're moving. So, in this problem, I am moving a negative 2. That's the number that I divided by on both sides. That's why it's going to be flipping the inequality. So it's all about the number that you're moving. As soon as I see that, what I like to do on the next line is I like to immediately flip my inequality, make it go the other direction so that I don't forget. So as soon as I divide by a negative, I'm going to flip it. Right now it's a greater than or equal to. I'm going to make it a less than or equal to. And so my final answer on this problem is x is less than or equal to negative 5 over 2. The way the inequality is pointing is super duper important because it changes the whole meaning of this question. This problem is saying I want all the numbers smaller than negative 5 over 2. And if you don't flip the inequality, you then have the complete opposite set of numbers, which is all the numbers that are greater than. So it's really important that you get your inequality pointing in the correct direction. Let's take a look at a couple more. Now, when we were doing an equation, I told you could cross multiply. I told you this because it didn't matter what side you wrote things on after you were done cross multiplying, because it was an equal sign. When we have an inequality, it really does matter what side things end up on. And so just to play it safe, we're not going to be doing any cross multiplying in this chapter. Instead, in a problem like this, where it says x divided by 3, I would do the opposite of division, which is multiplication. So I'll be multiplying both sides by 3. Now, at this point in time, you want to ask yourself, is the number that I'm moving a negative number? And the answer is no. The number that I'm moving is a positive 3. Since the number that I'm moving is positive, I will not be flipping my inequality. Even though my answer is a negative, and my answer is going to be x is less than negative 6. The number that I moved was positive, so the inequality stays as is. So again, it's not about what your answer is. It's not about what this number is. It's the number that you're moving. And we only really care when you're moving it by multiplying or dividing. Let's try another one. Okay. In this problem, it says C divided by 8. And so if I want to get rid of a divided by 8, I'm going to multiply by 8. Now, when you're multiplying by 8, you're multiplying by the whole number 8. So I'm going to put it as 8 over 1. 8 over 1, so it's a whole number. And again, I'm going to do a really quick mental check. I'm multiplying by a positive number, so I'm not going to switch my inequality. On the left side, the 8's cancel out. On the right side, you can either multiply straight across, so you can do 1 times 8 from the top up here, and 4 times 1 down here, and you'll get 8 over 4. Or you can do this thing called cross-canceling. Cross-canceling is a type of division. 8 divided by 4 is 2. Not cross-multiplying, cross-canceling division. And so my final answer to this question is C is greater than 2. Those were division problems. Our first example was a multiplication problem. Let's finish up today's video with some fractions. In this problem, it says negative 3 over 4 times W is greater than or equal to 3. When you have a fraction being multiplied by a variable, we're not going to divide by that fraction because you can't divide by fractions. Instead, we're going to multiply by the reciprocal. The reciprocal means take your fraction and flip it upside down. The reciprocal does not mean to change the sign of the number. So if this is a negative 3 over 4, when I take the reciprocal, it's still going to be negative, but now it will be 4 over 3. Now, at this point in time, I've noticed that I've written a negative number on both sides of my inequality. That means when I'm done, I should flip my inequality. So right now it's a greater than, and I might even write, if I was doing this on a piece of paper, I would flip it right now and make it a less than. On the left-hand side, the 4's cancel, 3's cancel, and the negatives cancel, leaving us with just the letter W. On the right-hand side, you can cross-cancel the 3 that was already there and the 3 on the bottom. And that leaves us with the 4 and the negative sign. Now again, I multiplied by a negative, so you'll notice that my final answer is W is less than or equal to negative 4. So I flip my inequality because I multiplied by a negative. Here's our final example for today. In this problem, I have n over 3, and I have a negative sign in front of it, and then it's less than negative 1. Now, you could just multiply by 3, but that would not get rid of the negative sign. So if you want to get rid of the 3 and the negative sign at the same time, you're going to multiply by a negative 3. That way the 3's will cancel and the negative signs will cancel. So I'm multiplying each side by negative 3. That means, and if I was writing this on a paper right now, I would flip my inequality because I multiplied by a negative 3 on each side. On the left side, my 3's cancel and my negatives cancel. On the right side, negative 1 times negative 3 is positive 3. Now, I do still have to flip my inequality, again, because the number that I multiplied by on each side was negative. It has nothing to do with the sign of the final answer. It's all about what number did you write on both sides. Now, I didn't do any graphing today, but that doesn't mean that you can't graph. All of these are graphable. I just wanted to really focus on when we should flip the inequality and when we should not. That's it for today.